Welcome to the video on angle-angle similarity. The purpose of this lesson is to introduce you to the angle-angle similarity postulate, as well as how to use it in a variety of proofwriting situations. First things first, what does the angle-angle similarity postulate says? It says anytime you have two angles of one triangle congruent to two angles of a second triangle, then the two triangles are in fact similar to each other. All right, let's go ahead and take a look at what this means. First things first, I'm going to give you a minute to go and mark your diagram. All right, there's not a whole lot to mark here. Hopefully you used a couple of arrows to mark segment MN parallel to segment JK. And they're asking us then to prove that triangle MLN, so triangle MLN is that green one right there, is similar to triangle JLK. JLK is that blue one right there. Well, based upon what I know about parallel lines, I know that anytime two lines are parallel, I know corresponding angles are congruent. Therefore, angles 1 and 2 must be congruent, and likewise, angles 3 and 4 must be congruent. So that gives me two angles in the green triangle congruent to two angles in the blue triangle, proving that our two triangles are therefore similar. So let's see now how this would look if we were to write it in a proof. I'm going to go ahead and start out by talking about those line segments MN and JK being parallel. We know that's a true statement because it's given to us to be a true statement. And because those two lines are parallel, that's what tells me that angles 1 and 2 are congruent, as well as angles 3 and 4. Remember, when you write your reason for this, you have to write about the lines being parallel, because unless the lines are parallel, those angles can't be congruent. So I'm going to start off first of all by talking about lines being parallel. So when lines are parallel, and I must tell exactly what type of angles these pairs are. They're corresponding angles. So at this point, I've established my whole basis for my proof. I've got two pairs of angles in one triangle congruent to two pairs of angles in a second triangle. I can therefore go ahead and state then that the two triangles must be similar. And as far as a reason for that, well, I've got my angle-angle similarity postulate. All right, so there's our first proof. Let's go ahead now and take a look at the second one. This one too, the givens have already been marked for us in the diagram, so there's not a lot to mark. But let's go ahead and take a look at what they're asking us to do. They want us to prove that triangle JKL, so if I look at the picture then, triangle JKL is that big purple triangle. They want us to show that that's similar to triangle JMK. And JMK is that little red guy right in there. Well, because of the whole perpendicular lines thing, I have two right angles. I have a right angle in the purple triangle as well as a right angle in the red triangle. That will give me one of the two pairs of congruent angles that I need. And now, taking a look at the picture, I notice that one of the angles in the red triangle and in the purple triangle are exactly the same angle. So if the red angle, or if angle J in the red triangle measures 60, angle J in the purple triangle must measure 60 degrees as well. They can't be two different angle measurements. So by the reflexive property then, angle J in the purple triangle and angle J in the red triangle are themselves congruent. So that's going to form the basis for my proof. I think this time, just to be a little bit diverse, I'm going to write a two-column proof. So I'll go ahead and get my statements and my reasons in there. And it really doesn't make a difference which order you get these in there, as long as you get both of them in. So I'm going to go ahead and start my proof by first of all talking about those perpendicular line segments. And hopefully you remember that perpendicular means forms right angles. So that's going to give me a couple of different right angles. That's going to make angle JKL and angle JMK right angles. So both of those guys are right angles. And how did I know that? Well, the perpendicular lines that I had in statement 1 formed right angles. And I'm going to cite statement 1 because statement 1 was where I had the perpendicular lines. Because those angles are right angles, I know that they therefore must be congruent to each other. As for a reason, I know that anytime I have right angles, they're always congruent. So there's my first pair of congruent angles. My second pair of angles are going to be the shared angles between the two triangles, angle J congruent to itself, and that's the reflexive property. So in statement 3 I have one pair of angles, statement 4 I have a second pair of angles. My two triangles thus must be similar to each other by that angle-angle similarity postulate. So that's all. I'm all set to go ahead and conclude that triangle JKL is similar to triangle JMK. And as far as a reason, angle-angle similarity. And I'm going to go ahead and cite statement 3 and cite statement 4 because those are the two statements which contained or included my pairs of congruent angles. All right, at this point, if you have questions, would you please do me a favor and jot them down at the bottom of the paper so that you can remember to bring them with you when you come to class tomorrow? Or better still, shoot me an email right now while it's fresh in your mind, and that way I will know what concerns or what questions you have before you even come to class, and I'll be prepared with some answers. When you come to class next time, we're going to take a look at some of these and get you some practice writing these angle-angle similarity proofs.